Hey everyone, welcome back to the College Algebra playlist. This chapter in the textbook is all about solving equations and solving inequalities. Alright, so we'll be taking a look at several different types of equations. Alright, those types include linear, quadratic, rational, radical, and absolute value equations. Alright, we already took a look at linear equations, so now we're ready to move on to quadratic equations. Alright, so let's dive into it. Okay, here we go. Quadratic equations. First, let's start with a simple definition. All right, an equation containing a second degree polynomial is called a quadratic equation. All right, here are some examples of quadratic equations. All right, so remember that the degree of a polynomial is the highest power that occurs. All right, so this blue equation, the highest power that occurs is 2. All right, so it's a second degree polynomial, so it's a quadratic equation. All right, same thing with this red equation down here, right? We have a power 2, so it's quadratic. And same thing for the green equation. All right. So next, let's talk about something called standard form. All right, what is a quadratic in standard form? Well, a quadratic equation, as we already know, is an equation containing a second degree polynomial ax squared plus bx plus c, and it's set equal to 0. All right, and a, b, and c are real numbers. Okay, those are the parameters of the equation. Remember, in the video on linear equations, we talked about the difference between variables and parameters. All right, in this case, a, b, and c are the parameters, and x is the variable. All right, if a does not equal 0, the equation is in standard form. All right, so it's a quadratic expression set equal to 0. All right, one way to solve this type of equation is to factor the left-hand side and use the zero product property. All right, what's the zero product property? I'm glad you asked. The zero product property states that if you have something times something equals 0, okay, we have j times k equals 0, then that means that j must equal 0 or k must equal 0. All right, where j and k are real numbers or algebraic expressions. All right, in our case, we're going to be looking at algebraic expressions. Okay, but it's true for real numbers as well. If you have something times something equals 0, then the first thing must be 0 or the second thing must be 0. All right, so let's try to solve this quadratic equation by factoring. All right, this left-hand side, right, this expression is factorable. Okay, we can factor it as x plus 3 times x minus 2. All right, so we have something times something equals 0. Therefore, x plus 3 equals 0 or x minus 2 equals 0 by the zero product property. All right, so we can set each of these things equal to 0 and then solve for x. All right, we're going to get two solutions here. On the left, we're going to subtract 3 from both sides. Okay? And that gives us x equals negative 3. Okay, so that's one of our solutions. And then on the right, we're going to add 2 to both sides. All right, and that gives us x equals 2. So that's another solution. So notice that the number of solutions matches the degree of the polynomial. All right, we'll talk more about that later in the playlist. But for now, we just need to know that quadratic equations give us two solutions. All right. What happens when we include y in the equation? That's the question I want to answer next. All right. X squared plus x minus 6. All right, that's the same quadratic expression we had on the previous screen. We had it set equal to 0 there, but here we have it set equal to y. All right. So remember, when we're trying to visualize the equation by making a graph, every solution to this equation here is going to be a coordinate point on that graph. All right. So let's try plugging in some values for x to see what we get for y, and then let's plot some points to see what we get. All right. Here we plug in x equals negative 2. All right. And that gives us y equals negative 4. All right. So we take this x value and we take this y value and we put them together as a coordinate point. All right, we have negative 2 comma negative 4. All right, that point is on the graph of the equation. All right, when we plug in -1, we get y equals -6. Okay, so we have -1, -6 on the graph. And when we plug in a 0, we get y equals -6. Okay, so we have 0, -6. And finally, when we plug in x equals 1, we get y equals -4. So 1, -4 is also on the graph of this equation. All right. Here are my 4 points. Okay. And when we connect the dots, we get a shape that looks like this. All right. So this is the graph of the equation y equals x squared plus x minus 6. All right. The graph of a quadratic equation is a curve called a parabola. All right. So this thing is called a parabola. And let's think back to the problem we solved before this, right? We had x squared plus x equals 6 set equal to 0. All right. When we solve that equation, right, when we solve this blue equation, we're setting y equal to 0, which means we're finding the x-intercepts of the parabola. All right. Remember, when y is 0, that means the point lies on the x-axis. All right. So we actually solved this equation already. All right, so we know what the x-intercepts are in this case. All right, it's -3, 0 and 2, 0. All right, we found those x values already. Okay, but now let's try a different problem. All right, let's try to solve x squared minus 4 equals 0. All right, once again, the left-hand side is factorable. Okay, this is the difference of squares, so we can solve it that way. All right. But first, let's take this equation to the right of the screen so that we can visualize what we're actually doing. All right, what we're doing is we're finding the x-intercepts of the equation y equals x squared minus 4. All right, we're looking for the x values of these blue points. Okay, so let's factor the left-hand side. All right, we get x plus 2 times x minus 2. All right, it's the difference of squares. And then by the zero product property, right, we can set each of those pieces equal to 0. All right, let's subtract 2 from both sides here, and we get x equals -2. All right, and then over here, let's add 2 to both sides, and we get x equals 2. Okay, so we know the coordinates of the x-intercepts, right? We have -2, 0 and 2, 0. All right. Let's try one more example. All right, the left-hand side here is factorable. All right, but this problem is harder, right? It's harder to factor this because the lead coefficient a is not equal to 1. All right, whenever we have a trinomial that looks like this, the best way to factor it is to use the AC method. All right, so in this case, we have a equals 4, b equals 15, and c equals 9. All right. The product AC is 9 times 4, right? So that's 36. All right. So we need to find P and Q. All right. Two numbers with a product of 36 and a sum of 15. All right. This is the AC method. So to find those two numbers, we're going to list the possible factors of 36 in a table. All right. Here are the possible factors. Well, actually, this table is incomplete, right? Also, these numbers, they're negative versions, right? -1 to -36. That would give you positive 36. But we're going to skip those, all right, because the answer is already in this table itself. All right? The answer is right here, actually. 3 times 12, right? That's 36. And 3 plus 12 is 15. All right, so that's the combo we're looking for. All right, so we don't need to look at the negative numbers. So I have P equals 3 and Q equals 12. All right. So we're going to split this middle term up into 2 pieces. All right, 15x, we'll split that up into 3x plus 12x. All right. And then this is when we use factoring by grouping. All right. So let's switch everything back to blue. All right. And let's group these two terms together and group these two terms together. All right. The GCF of these two terms is x, and the greatest common factor of these two terms is 3. All right? So we're going to pull out an x over here, and that leaves us with 4x plus 3. Okay? And then here, we'll pull out the GCF of 3, and we're left with 4x plus 3. All right? And let's not forget that we're adding these together, and we're setting them equal to 0. Okay? Then we notice that 4x plus 3 appears in both terms here. All right, so we can pull it out, and we're left with 4x plus 3 times x plus 3. All right? If that last step is tripping you up, all right, if this process doesn't make sense to you, I encourage you to go check out the video titled Factoring by Grouping and the AC Method. All right, that's the 15th video in this playlist. All right? So let's take our original equation and our factored equation to the top of the screen. All right? We factored the left-hand side successfully. All right? That took a lot of work. The AC method takes a lot of work, but it works. All right? It gave us what we wanted. All right? So we can set each of these pieces equal to 0 by the zero product property. All right? So let's subtract 3 from both sides over here, and we get 4x equals negative 3. And then let's divide both sides by 4 to isolate x, and we get x equals negative 3/4. Okay? So that's one solution. Over here, let's subtract 3 from both sides, and we get x equals negative 3. Okay? So these are our two solutions. Let's visualize this. All right? This is the graph of the equation y equals 4x squared plus 15x plus 9. All right, so when we solve this blue equation, we're finding the x-coordinates of these two blue points. All right, we found that x equals negative 3/4 and x equals negative 3. Okay, so those are the coordinates of the points we're looking for. All right, that does it for this video. Thank you for watching, and like and subscribe.